Alright, so for problem number 7 on the exam 2 corrections, that's the first one that I had to redo. It says to use implicit differentiation to complete each of the following tasks. So for part A, we have find the slope of the curve x squared plus sine y equals 2 to the e to the 2x power minus 1 at 0, 0. So originally I made a fairly small error and forgot to multiply by 2, so I reworked it. And what you're supposed to do is you take the derivative, so it goes from x squared plus sine y e to the 2x minus 1 and all that, to 2x plus cosine of y prime equals 2 times e to the 2x. Because this is basically a chain rule, the 2x is the inside, e is always its own derivative. So you bring the 2 down and multiply it. And since we took the derivative of y here, we have to keep y prime or dy dx. So then we come down here and we can just simply plug in our coordinates. So we plug in 0 for x and y and our x over here. And then this of course goes to 0. This goes away as well. And this, since e would then be to the 0th power, it becomes 1. So it's just 2 times 1. And then that brings us over here to the final part. So we then have y prime equals 2 times 1, which equals 2, our answer. Now the second one is a bit more complex. I messed up pretty bad on the original one, as you can see. So we got find the second derivative, y prime prime, or d2y over dx squared, if xy equals y squared plus 2. Simplify until there are no nested fractions, but don't expand the denominators. So overall, it's actually a pretty simple and straightforward problem. So since we have x times y here, we have to product rule that. Simply, it's x times 1 plus y times 1. And so we're just taking the derivative of everything like normal. And then this becomes 2y, this 2 just goes away. And since we took the derivative of y and multiplied it by x, we then have xy prime plus y equals 2y, y prime, since we also took the derivative of y here. So we can simply subtract the x and y over here. And then, since we have the y is by itself, and we have all the y primes on one side, we can then factor that y prime out. Which gives us y equals y prime times 2y minus x. And now here it's as simple as dividing this 2y minus x over and putting it under the y. So this gives us our first derivative. Y prime equals y over 2y minus x. So from here, we take our second derivative, and this is where it gets a little bit more complicated because we have to quotient rule it. To quotient rule, it is the high or the top, taking the derivative and multiplying it by the low or the bottom, and then subtracting that from the, you take the derivative of the top and you multiply that by the bottom. Then you take the top and multiply by the derivative of the bottom. So this gives us 2y minus x times y prime, because the derivative of y is just simply 1, so it's y prime, minus y times 2y prime minus 1. And that is also the derivative of 2y minus x. The x becomes 1, 2y, drop the y, just makes it y prime. And you also square the denominator. And this brings us over here. Since we just did that, we can then plug in our first derivative in for every y prime. And this allows us to do a lot of canceling and everything else, because these 2y minus 2, the x's cancel out here, and then we can just distribute this y across. And then that gives us this, y minus 2y squared over 2y minus x plus y over 2y minus x squared. And I had originally messed up on this as well, but thankfully I got help for that too. And because basically this y is over 2y squared, or 2y minus x squared, and so is this y. But this one, since you're basically dividing it by a 2y, I think of it as a 2y minus x over 1, so you're basically just going to have to same change, flip it, and that makes it a cubed. So our final answer for the second derivative of 7b is y over 2y minus x squared minus 2y squared over 2y minus x cubed plus y over 2y minus x squared. And that has been problem 7a and b.